All right, good morning. So it's week 2, lecture 3, and what I want to do today a little bit is I'm going to go over the required textbook, Cradle to Cradle. I finally got my, hey Maria, finally got my copy in the mail here, so I was just going to read a few things out of the front matter because it's, I don't know, it's been around a while, and it's one of the, I don't know if there's really a whole lot of best practices in here, but it's more of a philosophical treatment, if you will. The book that I'm writing, I'm trying to treat more as a best practices, and I think some of the things that we're going to do in this course is more hands-on. So you can kind of look at this Cradle to Cradle book as pointing out problems, and then hopefully you can look to the book that I'm writing and also to the Ted Carnes book as more of a solutions book, if you will. All right, so let's just get into the course shell and catch up on anything in the forums I might have missed. Hey, good morning. And then we'll look into the two texts. All right, I think I'm pretty caught up on this. That's good. All right, so week 1. Week 1's behind us. Let's just take a quick peek into. Oh, and if you haven't done so yet, go ahead and take this week 1 quiz. There's not really, who hasn't taken it yet? A couple? Okay. Did you, well, it's there. Take it by the end of the week. It's fine. And it's nothing, I mean, there's no right or wrong answers. It's mainly just to move through the course. So go ahead and take that guy. And then I'll also write up a little quiz for this week too, based on the things we talk about in lecture. Okay. And then also for week 2, what I'd like you to do, just go ahead and take a picture of your own waste stream. As Shelley was mentioning there, what we're going to try to do this week is go into the bullpen and dig through some of the things that are back there. A lot of what I've put back there, I've been putting that back there specifically for this course, just as sort of challenge problems. I feel that the students that signed up for this course are hopefully as committed to the whole recycling thing as I am, and just thought that might be a good opportunity to put our money where our mouths are and take care of it. Okay, so take the week 1 quiz, log into this forum. We'll discuss the forum on Thursday, but for now, I just want to look through a few things in this Cradle to Cradle book. So, like I said, I mentioned the fact that this finally came in the mail to me. The 2 authors are William McDonough and Michael Brungart. So let me just grab a couple things. I like the way the first paragraph or 2 reads. So here we go. Well, in the first little chapter says, "This book is not a tree." You pick up the recycling book and think, okay, so these guys are environmentalists, and you had to kill a tree to save a tree, I guess. But as it turns out, this book is not actually made of cellulose. They tell you what it's made of here in a little bit. So, at last, you finally found the time to sink into your favorite armchair, relax, and pick up a book, this one. Your daughter uses a computer in the next room while the baby crawls on the carpet and plays with a pile of colorful plastic toys. It certainly feels, at this moment, as if all is well. Could there be a more compelling picture of peace, comfort, and safety? Or, you finally made it to lecture. I'm sitting in my comfy chair up here. People have their computers, and we're sitting here on this carpet. But anyway, what he describes is pretty typical. let's take a closer look. First, the comfortable chair you're sitting on. Did you know that the fabric contains mutagenic materials? What's mutagenic mean? Yeah, something that's going to affect your DNA in such a way that it might lead to cancer. Heavy metals, dangerous chemicals, and dyes that are often labeled hazardous by regulators, except when they are presented and sold to a customer. So you've got hazmats going into materials, but then once they've become inert or reach some standard, then they're not labeled as such. As you shift in your seat, particles of the fabric abrade and are taken up by your nose, mouth, and lungs, hazardous materials and all. We talked about this a little bit last week too when I was down at Brennan's Wave making little plastic granules and really kind of wondering like how the heck do you control it? And you don't. Dust is always being made anytime you have two surfaces rubbing together. And so fabric abrade, as you said, particles of the fabric are taken up by your nose, mouth, and lungs, hazardous materials and all. Were they on the menu when you ordered that chair? Well, you didn't have much control over it because it was a consumer good. The computer your child is using, did you know that it contains more than 1,000 different kinds of materials, including toxic gases, toxic metals such as cadmium, lead, mercury, acids, plastic, chlorinated and brominated substance, et cetera, et cetera? Well, yes, sorry, there's no such thing as an organic computer. It's part of the sport. The dust from some printer toner cartridges has been found to contain nickel, cobalt, and mercury, substances harmful to humans that your child could be inhaling as you read. Is it sensible? Is it necessary? Obviously, some of those 1,000 materials are essential to the function of the computer itself. Well, in fact, they all are. What will happen to them when your family outgrows the computer in a few years? You will have little choice but dispose of it, and that's valuable hazardous waste will be thrown away. You wanted to use a computer, but somehow you have unwittingly become party to a process of waste and destruction. So just this morning, in fact, Shelley Mitchell was emailing me asking if anyone's actually done a study on e-waste recycling in Montana. I don't know the answer to that. I do know that there are several ways to recycle your electronics. I also know that there's a professor, Ed Rosenberg, on the main campus who's done a lot of work with the mine in Butte and looking at ways to reclaim heavy metals. So I think somewhere between where we are right now trying to figure out with post-industrial waste and what's going on with the natural environment, there's probably a solution between those two. So, and again, just to reiterate, this course I think is a really good nexus between environmental science and engineering. Environmental science pointing out the problems that we just mentioned here in the book, but then how do we turn the page and get towards better engineering practices? Okay, but wait a minute, you care about the environment. In fact, when you went shopping for a carpet recently, you deliberately chose one made from recycled polyester and soda bottles, and then recycled. Perhaps it would be more accurate to say downcycled. And remember last week we talked a little bit about what each of those little triangles in the recycling triangle mean. Good intention aside, your rug is made of things that were never designed with this further use in mind, and wrestling them into this form has required as much energy and generated as much waste as producing a new carpet. That's debatable, I don't. And all that effort has only succeeded in postponing the usual fate of products by a life cycle or two. The rug is still on its way to a landfill. It's just stopping off in your house en route. Moreover, the recycling process may have introduced even more harmful additives than a conventional product contains, and it might be off-gassing and abrading them into your home at an even higher rate. Okay, so he goes on and on about that, just kind of the reality of where we are with some of the products we use. He also talks about the fact that this is synthetic paper, and let's see, it's not cotton, it's not wood, but it's rather plastic resins and inorganic fillers. So in a lot of ways, it's just like the carpeting he was just talked about. It's kind of en route to somewhere, right? He also said it's a prototype for the book as a technical nutrient. Later in the course, we'll talk a little bit more about the biosphere and the technosphere, And a lot of times our waste streams end up being sort of a confluence between those things. I think what he's talking about in terms of a technical nutrient is just keeping the book out of the biosphere entirely. Another strategy might be, we're going to make this out of pure unbleached paper with some kind of vegetable-based ink, and then you chuck it off in the garden and it turns into soil. But I think what they're talking about here is sort of separating those two, the technosphere from the biosphere. Keeping in mind, though, that everything, vast majority of things that are now in our technosphere were once sort of part of the biosphere. Metals, etc., not being part of that. But anything that was once alive, part of the biosphere, anything, if this was truly from a plastic, it was also once part of the biosphere just a long time ago, right? Got buried, long chain carbohydrates, mined, purified. So this too might have been living matter a long time ago, and the sun might have put those carbon bonds together. All right. They talk a little bit about trees. They talk a little bit about the revolution that they're trying to found. They said this revolution is founded on nature's surprisingly effective design principles, on human creativity and prosperity, and on respect, fair play, and goodwill. And even just before the class started, we were talking about our field trip to the recycling center tomorrow, and Shelley was also mentioning that there are some practices there that might not be as transparent as they might be. So one thing that I think we'll notice throughout this semester is that any artifact, anything that's comprised of multiple materials is going to have, one good example is a power cord or a signal cord. So you look at this guy, it's got metal down the middle, it's got some kind of plastic on the outside. Once this is no longer a valuable artifact, it still has the two materials in it, right? It's got the metal, it's got the rubber. Shelley was telling me that a lot of times these ends are not as valuable because they don't have as high a copper content as the rest of the cord. So already there's a little bit of triaging going on there. The point, though, is that there's some value to somebody, right? So like when this thing was initially made, the iron, copper, and all the plastics had some value in their original state. In the book we were just looking at as well, he was mentioning how a recycled material might take as much energy to recycle it as using the raw materials. So that's something also we need to look into. All right, so a lot of things going on right there. So there's the paper. But when we go to the recycling center tomorrow, I do want to take the questions with us that I put out there for our field trip. And, not in an accusing way, because I know that they're doing the best that they can over there, but more in a helpful way. What can this class do to make the whole recycling process, based on creativity, prosperity, respect, fair play, and goodwill. Yeah.
So when they take plastics and like reuse them like to make our carpet,
Sure.
that's kind of scary. But plastic is still plastic. If you're reusing it for something, I mean, you have babies crawling on it, you're crawling on it. I mean, how healthy is that?
Well, it's a good question, and I think the best answer to it would be to go into the literature. So I mean, there's all kinds of plastics, and some are perfectly inert, and some are not so much. Yeah.
Some traditional building materials or materials that you would find in like modular types of homes, man, they off-gas constantly.
Yeah.
For several years.
Yeah.
that new car smell that we all love, it's just toxic fumes.
Yeah, I've recently learned a lot about the whole FEMA trailers. You probably heard about the formaldehyde that goes into making the plastics, and
Right, so in some ways your carpet, even though it is really pretty randy, is not much worse than the intended materials.
yeah. So I think what this book is trying to get to is that no material ever really dies. And in fact, the very first lecture I gave, I talked about the conservation of energy, which is a big part of the renewable energy program here. But this course is really more about conservation of matter. And so in the case of the carpeting, I think what those manufacturers are trying to do is take something like the number one plastic bottle that otherwise is going to go to the landfill or maybe somewhere else and squeeze a little bit more use out of it. So tough to blame them, but I don't know if there's any perfect solution there.
But if we just got rid of all that and just burned the hell out of it, got rid of it, use it and get it done, and just went back to glass. Because there was an abundance, and when you melt it, it doesn't lose its, it's like plastic. You only do it a few times.
Well, yeah, it's an excellent point. So one would be to put some policies in place where plastics are banned from the manufacturing streams and go back to glass. I think what we'll see when we get into the embodied energy portions of the course next week that's a tough one too, because you're sort of trading a toxic. Well, you're trading a toxic substance for a more energy intense process. It's when we look at embodied energy, I think we'll find that glass has a much greater embodied energy than plastic. But yeah, certainly something to throw in the equation. Okay, then it's the two authors. One's Bill, one's Michael, and they're kind of talking a little bit about their very early experiences with sustainability, with recycling, and here's one of his sort of eye-opening trips. He says, I accompanied a professor of urban development to Jordan to develop a housing for the Bedouin who were settling in the Jordan River Valley. There I encountered an even greater scarcity of local resources, food, soil, energy, and especially water. But again, I was struck by how simple and elegant good design can be and how suited to locale. So another big topic in this book is design. How do you sort of design the toxins out of your products? How do you use more from naturally less energy intensive materials? Then he talks a little bit about these goat hair tents that they're living in. It says when it rained, the fibers swelled and the structure became tight as a drum. It was portable and easily repaired. The fabric factory, the goats followed the Bedouin around. This ingenious design, locally relevant, culturally rich, and using simple materials contrasted sharply with the typical modern designs I had seen in my own country, designs that rarely made such good of local material and energy flows. So there's a lot to be learned and harvested from nature. I think that's kind of the point there. My wife and I always joked about taking all the lint that comes out of the vacuum bags and actually knitting a sweater out of the dog hair that comes out of it. I don't know if anyone's tried that, but there's a natural fiber, maybe not as good as the goat hair that these guys are using. But this is when I returned to the States and entered graduate school. Energy efficiency was the only real environmental topic considered by designers and architects. Interest in solar power had been piqued by the 70s when gas prices soared. I designed and built the first solar heated house in Ireland. A measure of my ambition, there being very little sun in Ireland, similar to Montana, similar latitude, which gave me a taste of the difficulties of applying universal solutions to local circumstances. So I think we're going to find there's never one perfect solution for any particular demographic or economic. Among the strategies experts suggested to me was building a huge rock storage bin to retain heat, which I discovered after hauling 30 tons of rock, not too bad, was redundant in an Irish house with its thick masonry walls. So there's where a little bit of engineering and thermal modeling might have helped him in his design, and not just kind of listen to the experts. And so here's another issue too. he went to design some of the first, we're trying to design some of the first green offices, but what they found, he said, I worked on indoor air quality, a subject almost no one had studied in depth, and this is in the early 80s. Of particular concern to us were volatile organic compounds, those are the nice smells we're talking about, and that new car smell. Carcinogenic materials and anything else in the paints, wall coverings, carpetings, floorings, and fixtures that might cause indoor air qualities or multiple chemical sensitivity. With little or no research available, we turned to the manufacturers who often told us the information was proprietary and gave us nothing beyond the vague safeguards of material safety data sheets mandated by law. So you can appreciate that too. You know, if somebody's making a profit on their special material, they're not going to tell you how to make it. Okay, and then there's a few things from Michael. I'm not going to go into it in too much detail, but this was fairly revealing. He says that he visited the largest chromium extraction factory in Europe. Chromium is a heavy metal used in large-scale leather tanning processes. It's also used in metals so they don't rust, and et cetera, et cetera. And he noticed at this chromium processing plant that only the older men were working there, all of them wearing gas masks. The supervisor explained that it took an average of about 20 years for workers to develop cancer from chromium exposure, so the company made the decision to allow only workers older than 50 to work with a dangerous substance. So there's one solution to the problem. A couple more quotes here from this very first chapter. He says, what about designs? And again, there's that word design. You know, how do we, as engineering technologists, make designs that loved all the children of all the species for all time? So, you know, a lot of times we'll put a design together that's going to last for a while, that's going to benefit us in the short term. But I think, as we know, we humans are just very late on the scene in terms of Earth's evolution, and it'd be nice to leave a better legacy that was friendlier to all the children of all species for all time. Okay, and here's the next one, kind of philosophical, but it says eliminate the concept of waste, not reduce, minimize, or avoid waste. We've had this conversation a few times before, and waste is inevitable. It's just a matter of how do you embrace this cradle-to-cradle concept so that everything finds its place in the stream. So, eliminate the concept of waste, not reduce, minimize, or avoid waste, as environmentalists were then proposing, but eliminate the very concept by design. I like this. We met in Brazil to see an early version of this principle in practice, a waste processing garden that was in essence a giant intestine for its community, turning waste into food. I've got some other collaborators here in the Bitterroot. We're working on a similar concept. Ted Carnes practices this as well. And what's the name? There's a tribe in Brazil. Is it Yamamoto? Am I pronouncing that correctly? I came across it, but I didn't highlight it. Who's read this first chapter? I should have highlighted it here. I thought I highlighted it, but I didn't.
We probably don't know.
That's okay. No, Brazil's a big country. Yeah. It'll pop up. Or I want to say Yamamoto. I've not been to Brazil, so I'm not familiar with them. But they're frequently looked to as a people living much closer to nature than the rest of us typically do. Okay, and then here's just the last paragraph in this first chapter. It says, consider this. All of the ants on the planet taken together have a biomass greater than that of all humans. Ants have been incredibly industrious for millions of years, yet their productiveness nourishes plants, animals, and soil, Human history has been in full swing for a little over a century, well, maybe more than that, yet it has brought about a decline in almost every ecosystem on the planet. Nature does not have a design problem, people do. So, and then let me show you one more thing that just came to mind when I read that. If you get a chance, I would recommend reading this book too. I had the opportunity to meet the author at the, oh, that's an earlier version too, at a meeting in Grand Rapids in 2012. So Russ Gennett wrote this book called The Chimpanzees Who Would Become Ants, and he sort of looks towards our global civilization as one that's becoming more ant-like rather than more primate-like. So a lot of different thoughts coming together on that. Okay, so nature doesn't have a design problem, people do. All right, with that, I'm going to stop the recording.